Welcome back to Robbie's Office Hours. Today we're tackling even exponents in trig integrals. Okay, so how does this work? Well, here's an example where both exponents are even, okay, in this case 2's. And this is honestly the worst case scenario because you have to substitute in for both sine squared and cosine squared. So you got to remember these identities. So you have sine squared of x that's equal to 1 minus the cosine of 2x all over 2. And then the cosine squared of x is equal to 1 plus cosine of 2x all over 2. And you have to use those when evaluating this integral, okay? So how do I do that? Well, I know sine squared and cosine squared are equal to that, so let's plug in directly. So this is equal to the integral. Sine squared is 1 minus cosine of 2x all over 2 times cosine squared is 1 plus cosine of 2x all over 2 dx, okay? Now, 1/2 and 1/2 is a quarter, so I can take that out front, so that's equal to 1 over 4 integral. Now, what am I going to get here? Notice it's a difference of squares, okay? It's 1 times 1, but then that term and that term will cancel, so I'm really going to be left with what? 1 minus cosine squared of 2x dx. Okay, so that simplified it a little bit, but notice that I have another cosine squared here, which is like, oh, fantastic. Now you might be thinking, hey, look, I could use the Pythagorean identity and write 1 minus cosine squared as sine squared, and I'm like, good for you, except for you're still in the same boat that you were just in. You have an even exponent trig function that you're still going to have to reuse that over there, okay? So let's go up and say, well, what is that going to equal? If I have cosine squared of 2x, okay, well, look, cosine squared of 1x is 1 plus 2 times the input over 2. So what is cosine squared of 2x going to be? It's going to be 1 plus cosine of 2 times the input, so 4x all over 2. Okay, so again, you just replace that input right there, and that's going to give you your cosine of 4x. All right, so then this becomes 1 over 4 integral of, let's see, 1 minus, okay, what's cosine squared? 1 plus cosine of 4x all over 2 dx. Okay, so what is that? 1/4 integral, this is 1 minus 1/2 minus 1/2 cosine of 4x. All right, bear with me, we're almost there. Is equal to 1/4 integral, okay, 1 minus 1/2 is 1/2. That's beautiful. And I get minus 1/2 cosine of 4x dx. All right, so let's come up here to finish this out. So that's equal to 1/4. All right, 1/4 times, well, the antiderivative of 1 over 2 is just x over 2, so that's nice, x over 2. And then when I anti-differentiate this, I could do a u substitution with u equals 4x, then du would be 4, so dx would be du over 4, so I'm going to have to divide by 4. So at the end of the day, what do I get? I'm going to get minus 1/8. Okay, so minus 1/8. And then antiderivative of cosine is just sine, so that's sine of 4x plus c. All right. Now, as a sanity check, I should just say, if I take the derivative of this, what do I get? Well, I'm going to get negative 1/8 cosine of 4x times 4. The 4 over 8 is 1/2. I get negative 1/2 cosine 4x. Bingo, I got the right answer. And the last thing to do is just to distribute the 1/4. So I get x over 8 minus, let's write it as sine of 4x over 32. Now, a lot of times people ask, they're like, well, wait a second. Why isn't the plus c inside the parenthesis here? And I'm like, I don't care, put it there. It doesn't matter. If you put plus c here, then all you're going to do is distribute a 1/4. So I'm going to get c divided by 4. Just call it another constant, c tilde. It doesn't matter. It's still a constant, okay? So I just get that plus c at the end. So there you have it. When you have trig integrals and you're evaluating them where they have the even exponents with sines and cosines, here's how you do it. You got to use the sine squared as that identity, cosine squared as that identity. Plug through and hope that you can just bear the algebra before you get down to something that's relatively straightforward to evaluate from a calculus standpoint. Okay? So there you have it. As always, if you like the video, like it, subscribe, ask me questions down below. These are my office hours after all, and we'll keep on going.